Okay, folks. Well, I apologize about yesterday. I'm not quite sure what happened to the video, so I'm going to go ahead and I'm record it again here. Um, but hopefully you had a good weekend. That means then, since we were set back a day, we will not take the exam on chapter 10 here until after we get back from the break. What I'll do then is, when we get back from the break, I'll present a video that will sum up what you have to know. When we get back from break, then I will make an announcement. So please make sure you take a look on Classrooms and check that announcement about when the review. So we will review for the exam, and so that exam that we'll take will be the week that we get back from Easter vacation. We will meet on a live Zoom session so I can go over with you the procedures for taking the exam. Make sure that you enroll into Edmodo. I sent out to you on Classroom the directions, instructions for enrolling, along with the code that you would need to enroll into Edmodo. So please make sure you get that done prior to meeting. Again, like I said, we will meet when we get back after Easter vacation. So again, the exam for chapter 10 will be postponed until after we get back from Easter vacation. And at that point, then, like I told you, we will meet and I will post it on Zoom. Please make sure you post it on Classroom. Please make sure you check. And then that will give you the date that we will meet to practice on the platform that I've chosen for the exam. Okay. All right. So with that said, then we do need to finish up with this chapter here, and I will start chapter 12 today as well. I've posted on Classroom for us the material for chapter 12. We need to get started with that. So we'll start chapter 12 today and continue on with chapter 12 tomorrow. And we'll leave it at that until after we get back from the break and after we take the exam on chapter 10. And so please take a look at it, and we will get started with it today. Okay. All right, so with that said, then, we left off with this problem on Friday. I asked you to work out this problem on Friday to give us a chance to practice how to come up with these molecular formulas. And remember, a molecular formula is the actual formula for a particular compound, for a molecular compound. Now remember, different molecular compounds can share the same empirical formula, and a defined empirical formula for you as the formula for a compound or for a series of compounds in which the atoms are in their simplest whole number ratio. And we were able to obtain those empirical formulas using the percent composition and use that in order to, from there, then we can obtain the molecular formula, which is the actual formula for a particular compound. If we know what the molecular formula, the molecular mass is, the molar mass is for the particular molecule, and we can compare that to the empirical mass for the empirical formula itself. And so the goal then at the end of this is to be able to obtain the formula for a particular compound. Now, we saw then in a couple of examples last week that sometimes the empirical formula does describe an actual molecule, an actual compound, but a lot of times it does not. So make sure you keep in mind then that when we are describing a particular molecule, that there's only one formula for that molecule. However, that particular molecule can have and can share the same empirical formula with other molecules as well. Okay. All right. So with that said, then, how do we obtain these molecular formulas? Okay? So the molecular formula is obtained from taking and first of all obtaining the empirical formula. And in this particular problem here, we are given the empirical formula already. So here, what they've done is they've calculated for the empirical formula. Okay, so there's your empirical formula. And remember, what they do then is they take the percentages of each one of the atoms in this compound, each one of the atoms in this particular molecule here, and use that to determine then the formula. So what we have here for the empirical formula is a 1 to 1 to 1. One carbon, one chlorine, and one nitrogen. Okay? So that's what we have for the empirical formula. And so this mass here, this mass here represents the mass of the molecule, the actual molecule itself, which we do not know. Okay, so let's go ahead then and let's take a look at how we work this out. Okay? So what we have then is we have the empirical formula. We were told then we have one carbon, 1 chlorine, and 1 nitrogen. This is the empirical formula here. Okay, so this is the empirical formula, which is a formula representing all the atoms in the simplest whole number ratio. What we want then is we want the actual formula, which many textbooks will refer to as molecular, even though the compound is an ionic compound. Okay, they refer to it as the molecular, which represents then just the actual formula. I'll write this as actual. Okay, which means then the ratio of the atoms, in this case carbon, chlorine, nitrogen, will be in a 1 to 1 to 1. But the subscripts here won't actually be 1, 1, 1. If we reduce it, we will end up with a 1 to 1 to 1 ratio. Okay. And so with that said, then what we want to do is we want to find then what are the subscripts, or what are the numbers that will go here that we can use to obtain the actual formula for the compound. Well, what we know about this compound is we know its mass. We know that its mass is 184, its molar mass is 184.5 grams per mole. Now, we said then that we can figure out then if we can get the empirical mass here. So this is the molecular mass of this compound with a certain number of carbons, a certain number of chlorines, a certain number of nitrogens, which we don't know yet, and which we will calculate for, but we do know its mass here. We do know the mass of the compound, and that you need to be given. So on the exam, when you get back, so then on the exam, what I would do is I would have to give you this. You just have to be able to identify that this goes along with this particular compound. Okay? So how do we obtain this? Well, we said then, remember, that there is a relationship between the mass of this formula here. We can obtain the mass of this formula because we can add up the number of atoms here. And the relationship here between the mass here and the mass here, the multiplier that we use here can be used to multiply here the number of atoms to obtain the subscripts for the molecular compound here. So we can use this multiplier here, multiply the number here through this empirical formula for us to get the molecular formula itself. Okay, so what you need to do then is you need to calculate for the empirical mass. Okay, so what's the mass of 1 carbon plus 1 chlorine plus 1 nitrogen? Well, I get 61.5 grams per mole. So that's your mass for the empirical form. That is 1 carbon plus 1 chlorine plus the mass of 1 nitrogen. That's 12 plus 35.5 plus 14. That'll give you 61.5. Okay, so make sure you know how you get this number. If not, make sure you combine CV. Okay. Now, with that said, then we need to find the relationship between these two masses. And if you notice, this mass here, the molecular mass, is about 3 times larger. It's 3 times greater. So the multiplier here to get from the empirical mass to the molar mass, the molecular mass here, is 3. So what do? We take that same multiplier and we multiply through here. So that means we triple all of these here. So we get then not 1 carbon, but 3 carbons, not 1 chlorine, but 3 chlorines, not 1 nitrogen, but 3 nitrogens, and there it is. That is the molecular formula, the actual formula for the compound with this mass here. And if you add up the masses of 3 carbons, 3 chlorines, and 3 nitrogens, you will obtain this mass right there. And that would be confirmation for us that we got it correct. Okay. All right, very good. So that's how we obtain the molecular formula, and that's the formula for this particular compound. So what I would like to do then is I'd like you to, let me go ahead and clear this out. Okay. I'd like you to work through this problem here. Okay, so I'd like you to take about 4 or 5 minutes, okay? Work through this problem here. And if you notice this problem here, they give you the percent composition. And what they're asking you to do here, and make sure you keep this in mind, what they're asking you to do here is to find the actual formula. So when they ask you to find the formula here, they're asking you to find the actual formula, or like we said, the molecular formula, which is what this textbook refers to as the molecular, and other textbook as well, the molecular formula for this compound. Okay. So go ahead, take about 5 minutes, roughly 5 minutes to get this done, and then we will, I'll work this one out for you. Okay, so go ahead and get that done, and let's see what you come up with. Okay, let's go ahead then, and let's take a look at this problem here, and let's work this out together. Let me go ahead and clear this out. Yep. Okay. So in order to get the molecular formula, okay, in order to get the actual formula itself, we need to start out and get the empirical formula first. And unlike the two problems that we did previously involving actual formulas or the molecular formulas, we're not given the empirical formula here, but we are given percent compositions. So in this particular problem here, we are starting from the very beginning where we have to use the percent compositions to get the empirical formulas, and from that we should be able to get the molecular formula if we know what the molar mass is for that particular molecule, Okay? All right, so let's go ahead and let's do this. So remember, with percent composition, in order to get the empirical formula, there are these 7 steps that you have to take. Hopefully you don't memorize them, but hopefully you just through practice you remember what you have to do. And so what we have to do first, remember, is identify all the percentages, and we're given them here. After we've identified all the percentages, we're going to assume that whatever this compound is we have 100 grams of it. If we have 100 grams of it, then 56.6 grams of the compound will be made of potassium. Okay? 8.7 grams of the compound will be made up of carbon, and 34.7 grams of this compound will be made up of oxygen. Okay, why do we need those masses? Because we have to convert all those masses into moles. So this is a grams to moles conversion, and make sure you remember how to do that. Okay, so if you don't, make sure you combine CME to get that extra help. Okay, so we're going to do this conversion. How do we convert between mass of an element and its moles? We need the molar mass. The molar mass of an element, remember, you can find directly from the periodic table unless the element is a diatomic element, and we only have a handful of those, so make sure you remember what those are. Okay, but here we want the masses of the elements, okay, and the particular atom. So therefore, we'll plug in here, and we can divide by the molar mass here. The molar mass of potassium, if you look on your periodic table, the molar mass is 39, so we're going to go ahead and we're going to divide by 39, which is the molar mass in grams of potassium. Same thing for carbon here. The molar mass of carbon is 12 grams, so we're going to divide by the molar mass of carbon. And then finally, we're going to divide by the molar mass of oxygen. And this will be 16 grams of oxygen. Okay? So here we're not talking about elemental oxygen, we're talking about the oxygen atom itself. So that's why here we use 16 grams per mole instead of 32 grams per mole. Okay? All right, so you plug that in, and you get your answer here then is 1.45 moles of potassium, 0.725 moles of carbon, and 2.17 moles of oxygen. So remember, at this point, then we have the ratios of the atoms. Okay, so we have 1.45 moles here. We have carbon then is 0.725. And then for oxygen, then we have 2.17. Okay, so those are the ratios, but they're not the simplest whole number ratios. So how do we obtain simple whole numbers? Well, first, let's try then. First, then we would divide by the value that's the smallest. In this case, then it's the moles of carbon. We'll divide by 0.725, divide that by 0.725, and divide that by 7.25. Okay? And then we end up with here 2, and real close to 2. Carbon obviously will be 1, and oxygen here will get it real close to 3. Okay? And so the empirical formula right now then is going to be K2CO3. Now, they want us to find the actual formula for this compound, and yet we don't have the molecular mass. We don't have the molar mass of this compound. So the question is, why is that? Why don't we have that? Well, you have to recognize in that one simple factor that that will help you with this, and that is, this is an ionic compound. And remember, with ionic compounds, okay, the ratios of those atoms, there's only one form. Okay, and so therefore the ratios of those atoms are unique to that particular compound. And so therefore there is no other compound that has potassium, carbon, and oxygen in this ratio of 2 to 1 to 3. So there it is. That is your actual formula for this compound, and you can stop right there. And that's the reason why for this particular compound, they do not give you, excuse me, the molar mass of the compound because it's ionic. If it was a molecular compound, then I would have to give you, they would have to give you the molar mass. But in this particular case, since it's an ionic compound, we can stop right there. Because remember, with ionic compounds, you always have to reduce the simplest whole number ratios because those ratios represent then the balance of charges between the cation and anion rather than the number of atoms and also the number of atoms that appear in that particular compound. Okay. All right. So with that said, then, folks, the homework for tonight, make sure you practice that and get that done. Okay. And then we will, I will take your questions. Okay. For those of you who can come by after school today, and then we will, I'll go over your questions with you. Okay. All right, folks. So with that said, then, that, folks, is it for chapter 10. Okay, so let's go ahead and what I'd like to do then, and let's go ahead and do this here. Okay. I want to go ahead and start chapter 12. Okay. And if you want to think about this here, the way that you want to approach chapter 12 in the study of the material in chapter 12 is that if in chapter 10 we were describing quantities of given substances, okay, that is the quantities we were describing the quantities of elements, the quantities of compounds in terms of moles, in terms of mass, in terms of volume. If you want to think about it, chapter 10 as that. What we're doing in chapter 12 is we're going to take that study of quantities and apply it to a chemical reaction. So stoichiometry is a study in chemistry where we're looking at quantities involved in a chemical reaction. So we're not only talking about the quantities of single substances, okay, of individual substances. We're going to take a look at the quantities involved in a chemical reaction. Okay? And so that's what we're going to be doing in chapter 12. And so in order to get that discussion underway, what you need to make sure you remember is what we learned back in chapter 11, because the balanced equation is going to be critical. A balanced equation is going to be critical for us to study quantities in a chemical reaction. And so you need to remember how to balance out these equations. And so what I would like us to do then, I want you to take this particular, this is number 1 from the chapter 12 problem set. So go ahead and do this. I want you to take a couple minutes and balance out these 3 equations here, describing 3 different reactions. Okay? And then, and that'll give you some practice. Because again, in chapter 12 here, what we're doing is we're going to study chemical reactions. And we're going to be studying the quantities, that is how much of the reactants and products are involved in a chemical reaction. And so in order to get that done, you have to balance the equations. So I'm going to ask you this here. Go ahead and balance these three equations. We'll review it, and then we'll get started with chapter 12. So take a couple minutes to balance these 3. Okay. Okay, let's go ahead and balance the equation. Now remember, when we balance equations, what we're going to be doing is we will be counting atoms. So make sure then that you remember how to count these atoms here. Okay, so I'm just going to go ahead and give you the balance equations. If you have any questions about how we balance these equations, make sure you come by and you see me. If you don't remember how to balance these equations, come by and see me. Now, you don't have to be able to identify the equations, so I will point that out to you right now. You don't have to identify what type of reaction it is, but you have to be able to balance it. Okay? So for the very first one, if you notice, this is a combination reaction that involves 2 compounds. In chapter 11, we learned about combination reactions between 2 elements. Here, and I did mention back then that combination reactions could involve 2 different compounds as well. And here is an example of that. Okay, so we have potassium oxide combined together with water to form potassium hydroxide, and the balance equation then it's going to be a 1:1:2. Okay, a 1:1:2 molar ratio, and so make sure you keep that in mind as we work through this. Okay. The second equation then is a combustion reaction. Remember, a combustion reaction is characterized by an oxygen as a reactant. This is a combustion reaction involving a hydrocarbon. So the products that will form, carbon dioxide and water. Remember, with the combustion reaction involving oxygen, what you want to do always is balance the carbons first, then deal with the hydrogens, and then balance the oxygens last. If you have to balance the oxygens by using a fraction here, go ahead and do so. But in the end, make sure you multiply through by the common factor in order to eliminate that fraction. Okay, so if you do it that way, then you're going to see then that you'll have a balanced equation of 1 29, 19, and 20. Okay, so that'll be the coefficient to balance out this reaction here. And for the last one, which is, remember this one, this is a single replacement reaction here. The balance equation then is going to be 2, 2, 1, and 2. Okay, and that'll balance out the reaction for us, the equation for us. Okay, so make sure you practice this, folks, and make sure you remember how to do this. If you do not, review it in chapter 11, and then come by and see me if you need more clarification. Okay, all right. So what we're going to do then, real quick, and I'm running a low on time here, what we're going to do then is, in this particular chapter, what we're going to do, like I told you, is we're going to be studying, we're going to be looking at reactions. Okay, so let's make sure you understand this. We're going to be looking at chemical equations. So make sure then that you review chapter 11 and talk and take a look at the chemical equations. And we're going to use that to describe the quantities of reactants and products. Okay, so we're going to be looking at the reactants and products, and we're going to describe how much of the reactants, how much of the products there are. Key to understanding this are those coefficients of a balanced equation, which is why we just finished up by talking about these coefficients. Okay, and so with that said, what we're going to do then, we learned about conversions in chapter 3. We used conversions some more in chapter 10. What we're going to do is we're going to be doing conversions, but this time though we're going to be converting between different components of a reaction, and that's what stoichiometry is. It's being able to convert between one part of the reaction to another part of the reaction. Essentially, you want to think about it in terms of more mundane daily activity. This would be very similar to what we're doing, to what you would do in cooking. You would, if you can follow a recipe, and we're going to be talking about this, if you can follow a recipe, I think you should be able to do this, because in a recipe, what you have the ingredients, and you have how much of the ingredients you need to use. Okay? And if you don't have enough of a particular ingredient, you have to modify it in order to make sure, you have to modify the amounts of the remaining ingredients in order to make sure then that you have enough to make your whatever product you're making, whether it's cookies or cakes or whatever it is in the recipe. Okay? And so what we have to do then is to understand that, we will talk about these, what are called limiting reagents as well, because those are the reactants. Those are the ingredients that limit how much of the product we can make. Okay? And so with that said, that's what we're going to be doing in this particular chapter here. We're going to be studying chemical recipes. And though I think the example works, I'm reluctant, remember, I'm always reluctant to compare chemistry to cooking, though cooking is chemistry, because here, what we're doing is we're going to be quantifying the reactants and the products, and being able to do some simple math with them. Okay, and so what we're going to do tomorrow, and we'll pick up with this tomorrow, is that we're going to talk about these quantities. Okay, and we're going to talk about the central unit, a central conversion factor in doing these conversions. That's what we call the mole ratio. But before we get there, what we're going to do then is we're going to learn how to interpret these chemical equations in different ways in order to obtain the information that we need to do this stoichiometry. Okay, and so we will continue with that tomorrow. Okay, please make sure you you get the homework done, that it's signed. It's going to be the last section in last assignment in chapter 10. And please take a look at this new material here so that when we talk about it tomorrow, you'll have a better idea of what's going on. Okay. All right. So very good, folks. I will see you tomorrow. If not, hopefully I will see you this afternoon, 1:30 to 2:30, with whatever questions you may have. Okay. All right, folks. Have a good day.